In this video, we're going to go through flux F versus luminosity L and distance D. We're going to look at a light bulb that's in a lampshade, and we want to find the flux on the surface of the light bulb. But first of all, we need to find luminosity and distance and define these. Let's start with luminosity. Luminosity is power, and power has units of watts. So we bought a light bulb, and we're going to stick our light bulb in our lampshade. And so we could buy a 40-watt light bulb, a 60-watt light bulb, or a 100-watt light bulb. So let's say today we are going to put in our lamp a luminosity light bulb of 100 watts. Watts is a power unit, therefore luminosity is power. Let's look at distance D. Distance is usually given in inches or centimeters or feet or miles or kilometers, but today we're going to be looking in units of meters, the SI unit of meters. Now, flux is a combination of luminosity and distance. Specifically, we're going to look at the luminosity being spread out over an area. So the units are going to be watts per meter squared. Those are flux units. So we know our luminosity of our light bulb. We want to find out the diameter of our light bulb. So let's say the diameter of our light bulb is 10 centimeters. Well, we want to convert out of centimeters into meters, into our SI units over here. So we need to build our railroad track. So you put a vertical line down and a horizontal line to represent a railroad track. And on the right-hand side, you put your conversion units. We want to convert from centimeters. We know we want to go from centimeters, so they cancel out, and we know we want to convert into meters. This way we can cross the centimeters out, just like numbers. You divide numbers and letters, and we want to leave meters on the top. So now we need a conversion. How many centimeters in a meter? Well, we know that there are 100 centimeters in 1 meter. So now we just need to multiply this out and divide it. So I'm going to change my pen color. First thing we're going to do is divide our units. We see a centimeter on the top. That's going to divide with the centimeter on the bottom. And we're left with only one unit. It's a meter. So we have our units now. Now we need to multiply. We've got 10 multiplied by 1, divide by 100. So you multiply across and you divide by the numbers in the bottom. So we got 10 multiplied by 1 divided by 100. So let's go get out our calculator. And here we're going to look at our Google calculator. So I just went to Google and typed in Google calculator. And so we want to take 10. We hit the multiply symbol by 1. We hit equals. And then we want to divide by 100. Equals, and we have an answer of 0.1. So let's go back to our document. We know that our answer is 0.1. So now we have 0.1 meters is our D. So I can put our meter here. So now let's go look at the flux. We want to find out what is the flux at the surface of the bulb. So we put our symbol F for flux, and the equation is the luminosity divided by the area that it's spreading out, which in this case is 4 pi d squared. 4 pi d squared. So now let's go ahead and build our railroad track. So on the top we have luminosity. We know our luminosity is 100 watts, so I'm going to put 100 watts here. And then down in the bottom, we've got 4 pi, so I'm just going to put a 4 pi here. And then I've got this d squared, so I'm going to put a parentheses. I know the d is 0.1. And meters. And I have to put the parentheses here because I'm squaring both items. I'm squaring 0.1 and I'm squaring m. So I get meters squared on the bottom and 0.1 squared. So now let's look at what we have to multiply and divide out. So what we have here is we've got 100, and this is a 1. There's nothing up there. 100 times 1 divided by 4 divided by pi divided by 0.1 meters squared. So let's go do that. 100 times 1 divided by 4 pi, parentheses, 0.1 meters squared. Let's get out our calculator. So let's hit all clear, AC. And we know that we're going to type 100 on the top. And we want to hit divide. We know we have to divide by 4. I'm just going to hit equal sign. I'm going to divide by pi. There's the pi symbol. Pi equals. Now I have to divide by d squared. So I'm going to divide by, I'm going to put a parentheses just like I did before. It's 0.1. Close the parentheses. Oh, I'm not going to do that. Take that one away. I made a mistake because I want to square it first. So I hit the x to the y. I square it. Now I close the parentheses and I hit equal. So my answer is 795, and I've got 77 over here, which is greater than 50, so I can round this up. So it's about 796. So let's go back to our answer, and we know we have an answer of 796. We have watts on the top. We have a divide by symbol. And the only thing left is meters and squared. We square the letters just like the numbers. And now we know the flux. The flux at the surface of the light bulb is 796 watts per meter squared. And that's how we find flux at the surface of the light bulb.